Hello, hi everyone, and welcome to the Node.js masterclass on streams. What's happening? How it's organized? Okay, you can follow along. So there's the slides, and there is a repository. So it is the repository, and you will need to clone these up. Okay. But first, you also need to follow these instructions. It's also written in the README of the repository, but the TLDR is that you need this. Okay. Also use Node v20. Okay. I've not tested this in others and put everything in a workshop folder, whatever. Important part here is you need the large file support because we are going to do some heavy data processing with streams. So because we are doing a heavy data processing with streams, we need this. Okay, so here we go. Perfect. So I've put the link here. If you need more, please keep asking. Okay. A couple of things about me. You probably know me, but if you don't, I am part of the Node.js Technical Steering Committee, also board member of the OpenJS Foundation. Created a lot of libraries on NPM, including Fastify, Pino, and a bunch of others. I work 8 years as a consultant focusing on Node.js. I have a newsletter, whatever, you can follow me there. But more importantly, I'm part of I'm one of the people that works on Node.js streams and maintain Node.js streams. And it's essentially responsible for most of the things that you will see in the slides and in the examples. So if you have bugs, you can absolutely report them to me because I'm probably the person that needs to fix them. Yeah. And if you can hear my daughter screaming in the background, well, I can do anything about that. Okay. If you know how to tame a 3 years old, yeah, please let me know. So one more bit. Oh, last year I got 22 billion downloads. So I don't know, you should probably, if we were in the audience, in a physical room, I will probably have somebody ask for some cents as donations, but no, this time is not. We are remote. But again, you're using my software even if you want or not want it. So let's talk about streams and let's talk about arrays, okay? Now, streams, a lot of people don't understand streams, okay? And don't understand the basic principles behind streams. And they think they're just pure magic. But streams are born, okay, to process data larger than our memory, okay? So I have a chunk of data, okay, that is bigger than the memory that I have available, or data that is partial, and I don't have it all in memory yet, and I want to start processing it as early as possible, okay? The point is, in those cases, I cannot use an array as a data structure, okay? So what do I use? Well, as I said, I use a stream, okay? And streams are just like water, okay? And the analogy is way, way there. Because all Node.js features, by the way, rely on streams. So you're using streams no matter what. And very few people understand them, and this part of it's my fault, and I'm sorry. But Node.js got too big too quickly to fix this. So what is a stream? Well, a stream is an array over time, okay? And the key part, it allows you to process infinite amount of data in constant memory. A stream, let me repeat this because a lot of people don't understand this, and they have very, very odd thinking about all of this stuff, okay? A lot of people think that stream are just a way to increase the speed of stuff or improve latency or whatever. Well, streams is a trade-off, okay, between memory and time, okay? Now, they have a nice effect of making things faster too very often because as Node.js and JavaScript as a garbage collector requires CPU time. So using stream and reducing the use of memory also reduce the overall cost the overall overhead of running a certain piece of code, making the overall system faster if we could clean up the data and process the data as it goes, instead of waiting to be available, okay? The most important warning that you will get in this stream, in this masterclass, is this. If you have all your data available in memory, okay, you do not use streams. Do not use streams. If you have all the data ready to go, do not use streams. Use anything but, okay? Chunking it down will only slow your application with caveats, okay? If you know what you're doing, you could technically still make some sense with this, but most of the time, if you have all your data available in memory, don't use streams. It's a very good choice. Now, why? Node.js, I've already seen these slides a lot of the times. You have your Node.js event loop, okay? And your Node.js event loop, it's processing the data through an IO from IO event queue, okay? Now, a stream as its concept, okay, it's built so that you can take a chunk, an event coming from the kernel, the operating system, and so on, process the incoming data, okay, and use it to do some calculations on the fly, so that you can produce a response more or less immediately. Now, this is the problem, okay? Can you, okay? And this is the important part. If you need to process all the data synchronously, just accumulate it all and process it synchronously. It's way faster and likely better, okay? Now, the event loop can also be viewed as a mapping. The event loop can be something that is idle all the time, okay? Minus when it's running C++ and JavaScript code. What does it mean for node streams? Well, node streams, where do they live? They live in JavaScript land, okay? So they are JavaScript constructs. So whenever you're working with all the machinery that we'll see, it all happens in JavaScript. This is the problem. Okay? This is a problem. It generates overhead because when you're dealing with those kind of callbacks, events, and so on and so forth, you're not processing any new events, okay? The event loop, as they say, it's blocked. So it's fundamental to understand all of this, because if you don't, you will essentially try to use streams for certain things that are not good for. And this is the reason. So streams, we said the Node.js is event loop based, and streams resides in the JavaScript portion. So it's just a JavaScript construct, okay? That's it, okay? Often, though, their implementation have a C++ counterpart, okay, that does the job of interacting with the operating system and doing all the processing, which it's event loop based. So, and this is the conundrum between the C++ layer and the JavaScript layer. So when we do all the stream processing, it's happening at the JavaScript layer, okay, on top, over all the things, okay? Let's talk about the key, most important part about a stream, okay? Imagine that you have a producer and a consumer. The key feature of a stream, and this, I want you to understand this, look at me very clearly, okay, and understand this very, 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 very well, okay? It's that the streams are there to slow it down. And you might think, what? What are you saying? Doesn't make any sense, okay? It does not, okay? But it's not intuitive, okay? Streams are there to slow things down. More specifically, streams exist, okay, to not overwhelm the consumer. So the producer creates data, the consumer gets the data. Now, let's assume that the producer can consume the data much, much faster than what the consumer can digest it. So where does this data go? Okay, the gist here is you receive 100, let's say the producer is sending 100 megabytes or a gigabyte. Let's say it's sending a gigabyte of data, okay? Now, it's sending it as fast as it can. Now, the important part here is that the consumer needs to be able to receive it. And systems like Unix pipes and TCP sockets and so on and so forth. What they do, they have what is called flow control mechanisms, okay, or back pressure, whatever, it's the same thing, that to reduce, okay, to slow it down, to push the consumer, to push the producer, okay. So the consumer can say, nah, slow down. You're sending them too fast, okay. You're sending data too fast. You need to slow down, slow it down, okay. Why? Because typically when you're moving data around, the consumer has a buffer that where it stores the incoming data. When that buffer is full, the data is lost, okay? But if you're all processing in memory, you can just crash for an out-of-memory error. And therefore, you are pretty much screwed. So the full point of streams is to slow it down, to slow down your application. That's also why it's probably better and faster if you can just process it synchronously to do synchronous processing. Or in one chunk. So like synchronous processing means I can do an asynchronous read it all, and process all my data in one synchronous block. So what it happens is that the data, you have a stream and you have the data, and the data, it's the consumer sends essentially a signal back to the producer telling, slow it down, folks. Slow it down. It's too fast. Okay? It's basically pushing back, okay, and say no. Consider that in reality, though, is not one single step. So real-world stream-based application have a producer, a consumer, and multiple transfer things, okay, in between. Each one of them, okay, can do this back pressure mechanism or this flow control mechanism. So the latest consumer can say stop now, and these will be propagated through each layer to arrive at the producer, which will slow it down and honor this. So this means that there is actually buffering happening at every step. So you have buffering happening at the producer, okay? Then you have buffering when you receive the data on the other side. And at each point, you have some buffering to do, okay? In Node.js, we call this high watermark. It's the amount of data that you receive before posing, okay? So you receive, let's say you receive 10 megabytes. If you send 10 megabytes, if it's over the high watermark, the consumer will say, no, I'm full, slow it down. I'm full, slow it down. So let's talk about Node.js, okay, and Node.js specifics, because all of this is generic stuff. So the first class that we're going to talk about is the readable class, okay? And readable is essentially the class that we use to read a source of data, okay? And in this specific case, we can read it with two main mechanisms. One is on data and the other one is on readable. We'll talk about them. So how do you create a readable? Well, you can create a readable by doing, you get your readable, you can create your class, you can specify _read method here, and look at it. So these will do a push. So you do this push to insert some data in the readable, and you do this push and you put your smiley here. And after you have reached 5, you push null. Pushing null means that the stream is full. Okay, so pushing null means the stream is done, is full. Okay, and then you can instantiate the stream, and with on data we receive all the data. Now you see, with on data, the stream goes as fast as it can. Okay, there's no back pressure, no nothing. On data spits out data as fast as it can. There is a pause function that you can call to pause the stream. So let's take a look at our code. Okay, here. So we are here. Let's go inside examples. Okay, now, and if we go, let's open up readable.js. Oh, yep. sorry, I need to exit it from somewhere else. I have a lot of windows open. You can't imagine how many windows I have open in my computer. So, sorry. Here we go. Okay, so here it is. Now you can see this. How is this going? Okay. Oh, maybe even too much. So here we go. So we are here. Okay, and we do our stuff. So we can run this thing, and we can do node readable, and you can see we got our 5 smiles. Okay. So if we want to implement back pressure using this interface, what we would do is stream.pose. And if we stream.pose, only do one, okay? If set timeout after 1 second, resume, you see now we have delaying it. So this thing allows you, as you can see, we have on data, which is essentially a very crude way of, just a 5 rows of event of data coming out of the stream, but and we stream pause, we can pause it, and stream resume, we can get it start again. Now, unfortunately, pause and resume pause is advisory only. So, well, this is bad, okay? Pause is advisory only. So there are streams out there, especially in the ecosystem, not on Node.js core, but in the ecosystem, that do not respect stream. This is because streams have been at a very, very turbulent history in Node.js, so a lot of odd stuff in there. Okay, so there is also an end event, okay? So we can even do a create read stream from FS, where we can use it to read our data. This is typical stream where I can do my stuff. And as we said, this is hard, okay? And it requires a lot of work, okay? Because we need to know when we want more data, okay? More importantly, though, we could do this with unreadable, okay? And it's actually better to some extent because we can do, we now pull the data, okay? We don't, we pull as much data as we want, okay? We do not pull it. So let's try changing this, okay? We pull the data, okay? So we could do stream on readable, okay? Here we go. This is not needed. This is not needed. Cool. Okay. Note that we need to do a while loop here. So stream.read will return a value up until here we go. Okay. So we return something up until there is data available. Okay. Okay. Let's run it again. Now, as you can see, all the data is available here, mostly because read_read size is synchronous, and this size here is lower than high watermark. By default, high watermark for this kind of things is very high. So, no, we need to lower it down. So if we put high watermark to maybe 5, okay, you can see what's happening. You can see that the first one, it's we get 2, okay. On the first chunk, we get 2, okay. Interesting. And it's all available all the time, mostly because all of this is sync, okay. So _read size is essentially done to schedule something, okay? So let's put it as set immediate here instead. And now you can see that we have all the readable events as we would expect, Note that these will have a very different result if we do process next tick, or I think. No, identical in this case. Okay. Cool. This is a pool-based mechanism, okay? So when the data is available, when it's under the high watermark, okay? Now, let's remove this, okay? If I remove this, I got the exact same data. Cool. So you need the set immediate, because if you don't have the set immediate in this specific case, okay, as you can see, you will get all the data in the first blob, okay? And let's put object mode true so that it will be easier for you to understand, okay? So you get all of them immediately, because this is essentially called synchronously up until the... Okay. It's called synchronously. All of this is synchronously called, okay? That's the gist. So there's no asynchronicity built in all this magic. Hopefully it's clearer. Let's keep going, okay? So as we've seen, Node.js stream are based on event emitter. Big problem? Yes. Very big problem. Okay? Very big. Or not. Depends, okay? Anyway, it's important to note that readable is usually more performant, but as you can see, it's a little bit harder, a lot of stuff in it. On data is fast, requires a little bit more work for handling back pressure, and it's lower, whatever. Now, let's talk about one of the most important new features that I added to streams long ago, async iterators. So async iterators are pretty great, okay? And I love them, and that's what they do. You can have a generator function, okay, that yield data, and you can do awaits in between, and then can be consumed with this pattern for await length chunk of the iterator. Works fantastic. So what you don't know is, or maybe you're not aware of, is that all streams are all node streams are async iterable. So you can get any readable stream and do a for await on it to process its chunks. So you can read the code, you can consume the streams not using on data or on readable and having a lot of complicated code with event emitters and callbacks and stuff like that, but just use a for await and promises. 9 out of 10, you want to use this thing, okay? You want to use this code. You don't want to deal with events, okay? Please, okay? If you don't know what you're doing, don't deal with events. They're probably too hard. This is built on top of the events, okay? So how does it work? Ooh. Okay. So iterator. Okay. This is it. So we can do node iterator. Ooh. And as you can see, we are literally processing the chunks. Just getting them and concatenating them. That's it. Pretty nice, pretty easy, pretty cool. Okay. Ooh. Okay, so now we can run iterator 2. Again, same thing. Let's do this. Okay. Note that let's do... And let's see what it says. Note that it arrives in one single chunk. Okay. Why? Because this is they do 64 kilobytes. So the chunks by default is for files are 64 kilobytes. So in this case, it's just one chunk, but it could be less, it could be more, depends. And there is an interesting question on how much overhead to plain event processing. Quite a bit, actually. It's actually very expensive to do for await. It's not great, but the key point of streams is to delay time for to consume less memory and use more time. Okay. So overall, it's usually a good trade-off. But generically, it's lower. So if performance of streams is your key discussion, you should probably not use it. But having said that, there are probably a lot of edge cases that you're not thinking you should handle. So, trade-offs. Something that is very cool is you can use the new readable.from helper to create a Node.js stream from a generator, which is fantastic. Because then you can actually very easily take any generator-based function or even just something that generates is just a normal generator or an iterator, okay, that you can put in there, and we just create a stream out of it. It's great, okay. It works with all the stuff that's an iterator. It's fantastic, okay, just plain fantastic. Very useful. Also for testing, for all the things. The counterpart of readable is writable. Well, what does it mean? We have two main components for this. Two main APIs, write and end. So, write and end. How do we use them? So, first of all, one of the greatest things about write is that each return false when the buffer of the writable has reached the high watermark. What does it mean? It means that you stop. It says it gives the caller a please stop. Okay. When the caller should start again, well, it should listen for a drain event, and when drain is emitted, it can start calling write again. Now, what's the catch here? The stream.write will never throw you an error if it after it returns false. So a lot of people don't care and keep calling stream.write what they want. But it's a problem. And you should not do that. You should actually do what is in this code that you can see here, and actually wait for the drain event. Now, you see that we're using the once helper. So there is this letter called once that you can use to interact with event emitter on Node.js. From event emitter, you can interact from event emitter into promises word. And this allows you the crossing of the two things. One of the main things that are on the main API that is the most overrated is .pipe. Okay, .pipe concatenates one readable with one writable, essentially flowing all the water from the readable into the writable. But it has a catch, a bad one actually. Error handling is damn complex. Like, it's so complex that you probably should not be using pipe as is. Really, don't use pipe. If you're using pipe in your code, you are actually doing it wrong. So stop. Let's show you. So you have a read stream, a transform, and a destination, and you're piping all of them together. Look at how nice this API is. Okay. And how much we have lost in opportunities. Okay, now the problem is when an error happens. When an error happens in any of those three steps, it's a little bit tricky, because you know what do? Do you close all three? Well, you should be closing all three, right? Because if you don't close all three, like if an error in the upper transform is triggered, then you will not be able to do any other processing, right? So you need to deal with it, and it's bad. So, and at this point, everything becomes so scrambled, so you might just want to kill all the processing and start from scratch or something like that. So the transform allows you, so essentially, pipe is problematic because it does not know about the pipeline. It does not know about the chain of streams. It only knows about the the one pair. So it's very tricky. So in order to fix this, we have added, another method. But this is the reason why this piece of code is utterly wrong. So you have a read stream and a pipe to a response on an HTTP server. And in theory, this sounds okay, minus when it doesn't. Because if the file is not the one that is being passed, you are in huge, huge trouble. In fact, that's the reason why we have the pipeline helper function that allows you to connect one readable to one transfer another to a writable. And in fact, it's probably the best way to set up serving files, but more or less all sorts of things. This is how you write a pipeline. So you have your pipeline, okay, and you do create read stream. You have an upper in between, okay, and a transform, and then you put to standard output, and then you have an error handling. Wow, okay, it's pretty great, right? So the answer here. So in fact, we can actually simplify this way better. First of all, we can use ESM, which is fantastic. Then we can use pipeline from stream/promises, which it's a pipeline. It's a promise version of the callback.js one that I showed you. And you have a read stream. You can do fs create. You can do all the processing in an async function. Okay. And note that this is better because this actually does a lot less buffering than the other one, okay? So it's pretty great. Well, as I said, Node.js streams mostly do work well with promises, mostly. And I say mostly because there are bad situations, okay? So you should take the mostly with a grain of salt, okay? Because when you see the bad situation, you will essentially start banging your head on the wall. Okay, let's see one specifically. So never ever return a stream through a promise. So you have a function, an async function. If that function returns a stream, you should really return. It should really not come via a promise. Okay. Don't do that. And if an API does that, either they know very much what they're doing, or you are toast. Okay, essentially, you're basically toast. So let me show you the point. So if let's take a look at this code. Okay, so in this code, we have a promise that returns a readable stream that's called destroy to destroy the stream. Okay, synchronously, and then resolves it. Let's say for validation purposes or something like that. So, and after that completes, we have we set the error event. Note that if we don't catch the error event, it crashes badly. What happens is that the queue microtask, okay, will catch the error, but if you run it via set immediate, it won't. Sorry, what? What did you say? What did Matteo say? So in one case, it catches the error. In the other case, it just crashes the process. This makes no sense whatsoever. Zero. But look, this is the reason. Okay? So this is the function in Node Core that process all the things. Okay? All the next ticks and microtasks. Okay? So the problem here is that the error event is emitted inside a next tick call. And when you come out from a set immediate, you are essentially at the top of this function. But once you go in, but once it's pinned, but then you execute the next take in the big while loop, in the while loop. Then you do the promises, which is run microtasks. And that's it, okay? So the promise will resolve after the loop is triggered. Dang. Sorry. So be careful here. So let's talk briefly about web and versus Node.js stream. So there's been, this is one of the funniest one because, where is it? Okay, no, one of the funniest one. Okay, and it's actually very cool because a long time ago, I did a presentation telling people how we could ship this. Okay, and it took us, I don't know, essentially laying out the groundwork to be able to ship Fetch one day. And last October, Fetch became stable. Last September, Fetch was marked as stable, which was a massive achievement for that grand plan. Okay, and it just happened. Okay, so I am very, very happy about this. Having said that, the web stream implementation in Node is slowish. So if you want to work on optimizing it, there is probably a lot of room to grow. How do readable the web stream work? Well, they have this kind of nice method called pipe to, pipe through, controllers. It's a very complicated class hierarchy. I'm going to include some examples because otherwise people will get in trouble. So what you can do is you can take a body from a response and pipe it through the text decoder, then do another transform stream, then do a for await loop to do all the things. Web streams can be horrible, okay? And in fact, I have seen these not documented well enough in the docs, is that most of the time they recommend you to behave recklessly and not implement back pressure, while instead you should be implementing back pressure everywhere. So how do you do that with web streams? Well, web streams have a pull function or a pull method. With pull, you can check it out, okay, and keep reading it, okay, whenever pull is called. And in fact, there is even a desired size thing. So let's do a little bit of exercises. A little bit of an exercise. First of all, are there any questions on this part? And while I'm waiting for your questions, okay, here you go. This is the desired size. Sorry. So are there any questions about this? So why don't people usually use stream in their apps? Because they are very hard to understand. So most people mess it up. And so they don't do it, essentially. Or they did it once, they read one tutorial, the application crashes, and then they say, oh no, it's too hard, I'm not even learning this. So I got involved into streams because I needed to fix them for clients, essentially. So for client work. Okay, what is used for streaming Node? Readable from the stream module or readable stream web API? Yes, exactly. Yes, exactly, Omaru. In a typical CRUD job, there aren't many use cases for directly using streams, or maybe because I'm not aware of it. No, there aren't probably. No, it's true. If you're mostly doing some CRUD, no. Okay, very interesting. There is a question of encoding and nodejs.org API stream. Okay, so class readable. Okay. Okay, default encoding. The default encoding is used when no encoding is specified as an argument to stream.write. So that's the default encoding, okay? And encoding, you get it here. So I don't understand. Where do you get the encoding options? Daniele Dev, mostly if you are using streams, you are in Node.js, okay? You should refer to the docs and try to understand the docs. I have seen most tutorial and courses to be wrong and incorrect at a very simple level. In fact, that you can see, you can track of the bugs spreading through those courses and things. So in the meanwhile, while you folks are writing, you can check out the repo. There is, sorry, when new transport, there is an option to encode. It's the same as default encoding. One is on the receiving end, and this is on the outgoing end. What is the problem? One is for readable, the other one is for writable. I don't understand, J-Roll, what's your question? Okay. It makes absolute sense to call it chunk because it's a chunk read from a stream. So why chunk is a problem? Oh, yeah, that's why I understand it. I don't know. That's the reason that's my reason. Yeah, exactly. You are absolutely right. You want to add, you don't want to add all of them up and concatenate all the things, and then the process is completed. You have a stream, unless you need to process it as a single chunk, as a single blob, okay, as a single individual block, you don't really, you should keep it as a stream. But there is some certain file format, for example, a certain type of processing that requires you to have them as a single blob. So you parse it, you load it all in memory, and then you process it. Is it bad? Yes, but very often it's the only thing you can do. So there is that. In my experience, that is a very common case. It's not. It's not just. It's not. It's the uncommon part is that you can do stream processing. So, for example, let's consider it in this way. Let's say you want to load a very large JSON file, which is very common. When you're receiving a large JSON file, you really need to load it all in memory, otherwise JSON parse will not work. So, and this is true for a lot of other DOM-based things, okay, such as protocol buffers, all the things like that, okay? Yeah, you have a protocol buffer object, it's you cannot stream that, okay? It's a single thing, okay? So, yeah. There are a lot of data structures that needs to be read completely synchronously and processed synchronously. So, okay, so there is a good question from Borello. Let's suppose you are working on an application, need to use large data, process them, and write them out. What are the best practices to use in this case? Well, we can check out our repo for the exercise because I think it solves your question. There was a question for a pipeline. What happens on next tick is if it's not awaited. Is it closed? No. Awaited. If you await a pipeline, it will be. You will be waiting that the full pipeline, all the streams are closed. So that's it. Cool. So this is the exercise that we are going to do. Okay. So So once you have cloned the repo, okay. No, sorry, J-Roll. Await will not force the stream into a promise. You need to use pipeline to do the thing, okay? Or if you do for await and to process the stream, that's the correct way to read from a string using promises. Now, if you all have my repo, you can do the exercise, okay? So first one is let's do a bunch of synchronous processing. So in the repo that I've created, which is this mcolina streams training, you have Wikipedia, okay? Those are a bunch of files that are broadly compressed. They are gigantic, alpha gig each. They are very big, okay? And we want to process them and count how many pages. This is just a dump of Wikipedia. And there is this stressor file that you can use to do the processing, okay? So the first exercise is to do it synchronously. So decode the decompress the file, then use XML to JS to parse it. All of this synchronously, and see and explain the pain. Now, if you want to cheat, there is sync result with the result. There is a good question, and one more good question, which is a hint on typing stream while all of you does the exercise. Okay. While you can all do the exercise, I'm going to put back the requirement so you can copy it if you haven't. If there is a question, any hints on typing streams? Why is not a thing yet? Well, because types node is used everywhere, and streams are used everywhere. And I think if we change the types of types node to handle this properly, it will explode in your face everywhere. Like, it will break everybody. So generically, it's, if you do the typings correctly, you are in trouble. Essentially, you will be in trouble. That's my take. But with the latest things that were shipped in the latest TypeScript 5 and so on, you might actually be able to do it. Like, there is a lot of new keywords, a lot of new states, and maybe somebody will send a pull request. Okay, somebody recently has been able, I think, to add some very good typing for event emitter. So maybe there is some hope. Okay, but yeah, and more question. Is there a list of use case for readable streams? I can only think of videos and maybe a stream of IoT data. Well, there is only one big use case. It's fetch. Fetch is based on readable stream, on web streams. So because fetch is based on that, and everybody want to use fetch, we had to have your readable stream. I'm not doing a training course about streams ever, or not ever, but at least for the next 2 years. Okay, I'm currently focused on working on Platformatic, which is my startup. So if you want to do some very good Node.js and build Node.js servers, Node.js APIs very well, check it out. It probably does a lot of nice things for you. There are a few videos on our YouTube that explore you how to use Platformatic. It works great. This is a question from Duder. I assume that it has to be data that you can actually render, present to the user system in piecemeal. If it was a large email, for example, would we render pixel by pixel? I have no clue. It depends on the renderer. So there is this way of laying out images so that it can be rendered chunk by chunk. So technically it's possible, but to be honest, I would not do image processing with Node. If you need to image processing, well, I have done image processing with Node a long time ago, and again and again and again. So there are a few services these days that you can just buy it. It's probably cheaper than building. But essentially, it goes that you wrap ImageMagick, and you pass an image to ImageMagick, spit it out, then you put that image in cache. It's great. I would love to be able to natively attach metadata to stream pipe to a request response instead of having to add them at the first chunk and enter in the browser. I don't understand this question. Sorry, can you repeat it? Can you write it? Because I have no clue. When you receive a file on HTTP lander, oh, this is a good one. When you receive a file on HTTP handler, why is it not more efficient to read the file by means of the stream? This is a great question. Okay, so it is the problem. You are receiving data. You are receiving incoming data a lot. Okay, and you receive all this data coming in. Whoa, how it is going? A lot of data. Okay, and now you have two options. Okay, you have a server, right? A server is a limited amount of memory. If you buffer all that memory, if you get all these files and memory with the data that are arriving, and you accumulate it in memory in the memory of your process is likely go out of memory. You have essentially a denial of service attack ready to go for bad guys. So What you do instead is you take the stream, that incoming stream, and start streaming it to its destination. So only a limited amount of memory is passing through your process. And that's what you do with, and that's why you use streams, okay? So the efficiency comes of not having all this data in memory, but it's also a security concern. And the destination can be S3 or it can be a file on disk. Okay, it doesn't matter. Yeah, exactly. So there is a very interesting question. When I'm sending metadata like the estimated total chunks from Node.js to the browser to display a progress bar, I either have to use the first chunk or set a response header like X total chunk. Yes, that's exactly what you should be doing. It's exactly what you should be using. I typically recommend to use X total chunk, but this is my recommendation. Did anybody start working on the exercise yet? Still going. Okay. It is a repo. There are instructions. You need the install the large file system because otherwise you are in trouble. They are big files. So you need the very large file system. So good. So Vitali, I think. It says, I want to build a web app for a sync file exchange between user. People will download files using web client and other people can download those files. How should I do with streams? Well, typically, how I would do it, I would use, build it on top of S3. So what I would do is I would send my user, to upload the file. I will generate a pre-signed command for S3 and have the user upload straight into S3. Then have a little server that reads from get a stream from S3 and stream the file down, essentially. Or do the same thing and do a direct call to S3, but generically it's better to put a CloudFront in between. So it depends on the pre-sign for downloads. It depends if it needs to be public, private, and so on and so forth. I generically prefer to have go-to URLs and stuff, but it depends on the type of sharing that you need to do. Yes, well, let's take a look. Sync works? Maybe. Okay, so yes, sync does work. Okay, so let's take a look in sync start. So sync start, okay? So this is the stressor, okay? Fine. Let's go in sync result, okay? So this is the result of my of the work for synchronous processing, okay? And so and you can run it easily, okay? And we have two commands here. So in package.json, one, two, and all, okay? So let's take a look at it, okay? How does it work? Well, first thing, we read the file. Once we have read the file, we parse the file with broadly decompressed sync, and then we do parse to string, and we extract the page number of pages. Okay, good. Let's try this. npm run 1. Okay, it's running. There is this little utility that's called CLIMEM. Okay. Oh, no. Sorry, cat package. Okay, yep, run CLIMEM. Okay. The CLIMEM that you can use to verify how it's going with the memory, and is going to plot and extract the memory data in real time. So, and it's yeah, you can. Oh, maybe it's too small. Yeah. Okay, you can see the memory going up like crazy up. Okay, we have a 2 GB almost. It's going, wow. Ah, it crashed. It's too big. If you, at some point, it's too big. Well, first of all, you have consumed 3 GB of RAM of memory. So there is the question of memory. But we have reached a point where the string, the incoming stream is actually too big. You cannot parse it with a stream. So, ouch. Doesn't work. So how do you do it? And also it uses 300 megabytes. So it's 3 gigabyte of memory. So which typically it can be or it can be not be a problem. So the solution is to do streams. Streams all the way down. So there is an async start folder and you can follow up the README. So let's go and take a look. Okay, so we have a bunch of to-dos. Oh, this is probably not needed because it's already, yeah, whatever, already included. Anyway, so you have a few things, okay? A few to-dos to start. So we have a start function, which reports create a write stream for page file name, then write the header. So here we want to do two things, okay? We want to parse the files and provide a pages.csv with an ID and title of each page. So we need to create a write stream, write the header for the CSV file, iterate over each incoming incoming file, and call parse async in series, and then and the writable stream, and wait it's all flushed out. So Miguel, I think you got the gist of why you need streams from time to time. At some point, there is a amount of incoming data that doesn't fit the either Node or V8 or JavaScript. It's just too big. Okay, hopefully that you got your thing, your question. So streams all the way down. And if you have more questions, I'm very happy to answer them. And by the way, all of this is brought to you by Platformatic. Can you see the thing? No. Can you see the thing? Maybe. Yay. We have good swag. Everybody always say that we have good swag. So, okay. Still regarding the previous question, does the back pressure extend to TCP socket? Or the large file is loaded into server memory anyway? Absolutely. The back pressure is extended to the TCP socket. Absolutely. It's pushed down to the downstream. Yes. Oh, new questions. Okay. Does a pipeline automatically handle back pressure? Absolutely. Yes. Yes, and more yes. Of course. All of it. So much fun. Okay, so let's talk a little bit. Let's show you a little bit how it's the async start, how the solution for async. Okay, so let's take a look at, first of all, at the start function. So the start function, create a writable stream, write the ID and title, which is the header of our CSV file, and then parse the iterates over the incoming files and call parse async with the file and the writable stream. At the end of it, it calls writable end and then await for finished because it might be that the writable needs some time to process all the incoming data. And this is our pipeline. Okay, so with the pipeline, we start a readable. We do the broadly decoding. Then we use this library called the saxophonist, okay, which is a little library to do sax processing in a stream fashion. It's pretty good. Okay, I wrote the thing for this example. No, not for this example, but a long time ago. Saxophonist, okay, and which gives us a chunk, and then we take a chunk, okay. And as I showed you, you can process in pipeline. You can just pass in an asynchronous generator function in and just use it to transform your stream, which is way faster, which is easier than creating a transform and doing a lot of other work. So just do this, okay? And end false to tell the pipeline to not end the last one, to not end the writable. So how does it look? Okay, So let's take a look here. Let's open two windows, okay? So one can do npm run all, and then npm run CLI mem, which shows us our memory graph. And our memory graph, it's, here we go, here you go. You can see that now memory is nice and steady at 134 megabytes, essentially. Pretty good. Like EEP is like 16 megabytes or something. Like super nice. Really. Like we are passing immense files, okay? And this is actually super steady. Like super steady. This is a difference from using streams versus using synchronous processing. Note that with the synchronous processing, a lot of the stuff was blocked, okay? And the event loop was not ticking, okay? With this, the event loop is ticking, so our graph actually updates, okay? And you can see it, that the graph updates. Cool, right? And we extracted 150,000 pages from those archives. Pretty great, right? Look, we can do a lot of processing with this system. We could extract all of Wikipedia and put it into another website. And, you know, profit. Maybe it's a little bit evil, but who cares? No, I'm joking. We don't do that. Those things have their own license, by the way. There is in the Wikipedia folder, there is a license for those files. So, so what can we do here as a follow-up? Okay, so let's open up our stressor again. So we have a few things that we can do. The first one is we could essentially parallelize. Okay, so first of all, let's try this. Instead of doing a for, okay, let's try and see what it happens if we do a promise all. Okay, so instead of doing the for loop, and processing them in parallel, one at a time serially, we can process them in parallel. Let's try. Okay. Okay. Now you can see that we have a way higher memory consumption now. Before it was 100 something. Now it's 200. Okay. And also the average thing is actually way lower. Okay. The memory is higher. It's like 50 megabytes before of the heap. Now you can see that the chunks are taking longer. Like the other one, the chunks were completing one at a time way faster. Now the total chunks, the chunks were actually way, it took overall less time, but each individual thing took longer, okay? So, trade-offs, okay? More memory, so more memory, less, more memory and more speed, more throughput, okay? Let's run it again and check on the CPU, okay? Because that's probably one of the biggest limiting factor. So instead of doing this, we can use htop to monitor our CPU usage. So let's do npm run all. And it's now, you can see that this is the CLI, the stressors is running at 130% CPU. Like how it's 130% CPU? Well, the reason why you're running 130% CPU is because a lot of the decoding and stuff like that and reading and so on and so forth all happens of the main thread. So, and therefore it's that. Now we have finished. You see that when it finished, it was slowing down. Okay, on the CPU. It's pretty cool. Right? We can process a huge amount of data very quickly. Now, there is a catch though. If you do this promise all, if the number of files is massive, it will explode on the memory usage. Okay, so you typically don't want to do that. What is the memory space usage that you do, Borello? You're missing some memory usage. What do you do that you're missing it? CLI mem? This guy? This memory usage with CLI mem? You don't see the graph. There is a reason probably. So if you go in Colina CLI mem, this is a nifty tool. You will see you might be missing. What operating system are you using? Ubuntu. You might be missing the fonts. So let me see. Blast contrib. Here you go. Yeah, this has been long ago. Yeah, you need you're probably missing some fonts. So it's or your terminal cannot render them. I have a feeling. I don't recall, to be honest. Draw while. Yeah, it's Unicode Braille characters, okay? And you need to enable them somehow. Like, this is the reason. Yeah, something like that. Yeah, okay. So if you do that, you don't see it. You need to do 2 commands, okay? So on one terminal, you do npm run all, and on the other terminal, you do npm run CLI mem. So you need 2 terminals. So, okay, very interesting question. So you have, let's say you have one readable stream and you want to pipe it in 2 different writable, so the data is copied in both writable stream. How to do that correctly and efficiently? So probably the best way to, so two things. First of all, if you do, so you have a, okay, let me try to be as clear as possible. There is, if you need, if you want to handle, like, you can do manually, so you can, but you will need to do just use pipe. So pipeline, assume the full thing is a pipeline, okay? So it's probably very hard to do it with pipe because of the error handling. So you need to use pipe manually and then close the streams manually in case of errors. Okay, so if you take a readable, if you take a readable and then you pipe it to run writable, and then either writable, it works correctly. Okay, so Borello, you need to run the first command and then the second command at the one in 2 windows. Okay, so one window, the other window, and then you run. You don't expect that the first complete needs to, while the first run, the other one needs to go. Okay. I have no idea why you're getting that error, Bikohana. Probably because you don't have the large file things installed. So there is the large files. So you're not getting you have not downloaded the large files. Did you? Okay. I have no idea why you're getting that error. Broadly is such an odd zipping file. Very odd. You might want to decode them and encode the files. It's fine. CLI mem works because the main process exposes a port, okay? And the target, and when you run npm run CLI mem, it contacts that port. So one and the other. Bing. Yes and no, Shubham. Yes, there is. You can use my module. I always have a module for you. So clonable readable. There is a clonable readable module just for you. Works great. 2 million downloads per week. So I don't know. Here it is. Basically, that's what it does. but you need to create all your clones before starting. And know that you might pipe all the clones to start the flow. Cool. So, yeah, perfect. Are there any more questions, folks? I think I answered all of it. You were able to run the example and make everything work. Technically, somebody can download the wall of Wikipedia and just process it all. So, before we finish, okay, let's go. Yeah, check out Platformatic. Okay, you're probably familiar now because you came in and you're receiving some nice emails from us. Let me, so please take a look. Okay, so yeah. And yeah, the next one, as Alex is saying in the chat, okay, is going to be building AI apps with Platformatic. So how do you leverage LLMs and all sorts of things with the help of Platformatic? So hopefully you will like that one. Okay. So maybe, let's see. Okay, we have been working for you. So, and you know, I really like this pose. I think it's good. I really like this pose. Okay, thank you very much for watching. Okay, and thank you for being here. Okay, I hope you liked it. So, yay! Thank you, folks. If you have any more questions, any whatever, please shout. Otherwise, I will say goodbye, and we can see you next month. Does Platformatic leverage streams, Matteo? Yes, of course. Platformatic is full of streams internally. We have streams all over, okay? In fact, there are so many streams that some of those problems that we have eaten were actually very hard to fix. So, but a lot of the magic that we can do is because we have a lot of streams now. So we can do a lot of back and forth very easily. Like, one of the features that leverages streams is this. So let's say that you have CDTemp. Okay, let's see that we have this app. Okay, let me check what is in here. Okay, should be good. Let's start it. Okay, this is a Platformatic app. Okay, and okay, and we can open it. Great. Okay, see logs. So we can do PLTPS to see Platformatic app, and this is FFF1. So what we could do, so we have a command called Platformatic logs. Okay, and as you can see, we see all the logs. Okay, and if we refresh it, you get all the logs. Okay, and this is from the process, but this is like just our common logs, and it allows you to access the logs. Okay. And what is the elevator pitch for Platformatic? Well, look, it's written there. Your node backend on autopilot is written to write your Node.js backends. And yeah, check it out. Cool. Oh, one more thing. What you can do, for example, you can also do inject. Okay, and it's... You can just do inject to do API calls. And again, all of this is built on streams. It all discovered automatically, it just works out of the box. So it's, yeah, all of this is built on streams. A lot of streams for this, like lots and more streams. So a lot of streams, a lot, which probably a good thing, but a lot. Yep, I knew Big Kahuna. I actually knew. Cool. Is it possible to record the response body when using Nginx? I have no idea what you mean. What is the difference between an application and a stackable? Use an application. If you just try to initialize a new project using Platformatic, initialize an application. That's fine. A stackable is to be able to create something, a library that to create a library that can be reused in multiple applications. So I want to log the response body in Kibana for analytics. All my API requests are routed via Nginx, and yes, by default, do not store the responses. So it's their way around it. What, unfortunately, Shubham, doing that is essentially, like, it's mostly legal in in the EU and possibly in a lot of other countries, in the sense that your responses included PII very often, and you will need to sanitize your PII very cleanly before putting them there. So to be honest, you really don't want to do that. It's actually very hard to do it at scale. If you use a framework like Fastify, you can do this. There is a hook called onSend that you can use to intercept the request and collect it all out and then do whatever you want with it, even store it in Elasticsearch. But I would say don't do it. It's probably not worth it. Is there something inherently wrong with long-running requests, 1-2 minutes on Node? Nope, there aren't. Minus the fact that they will consume memory for 1 or 2 minutes. So it means that somebody can essentially consume all your memory and make your process crash. But that's the only bit. Okay, I think your time is up. I will say goodbye. Bye-bye, folks, and see you next time. Bye-bye.